Hello everyone, and welcome to the 19th video in the TypeScript engine tutorial series. So in this video we're actually going to start on our creation of our collision detection system. But before we can do that, there's a couple things that I want to fix and adjust first to be able to support that. So one of the first things I want to do is I need to fix something in the input manager, because the way that it's actually set up right now, I can't access the debug console because I'm actually suppressing all the keyboard events, which is actually what I told it to do, but I need to turn that off right now. So in the input manager, if I go down to the onKeyDown and onKeyUp events, this right here is actually what's preventing me from being able to debug. So I'm actually going to comment that out and temporarily return true. And I'm going to do the same thing for key up, just to be sure that that none of the events that I'm going to need are going to be blocked. And this is something that I'll definitely want to switch back when I go into production mode with this, but for now I just need to disable that event suppression. So if I go in here and run it, now I can get my debug console up. Great. So the next thing that needs to happen is I need to add origins. And what I mean by that is, right now, if we look at the sprite that's rotating, we'll note that we're rotating by the upper left corner. And that's fine for this example, but most of the time that's actually not what we're going to need. We're going to need to offset that somehow. Maybe we want to rotate it by the center, which is going to be the most common, or maybe we need to rotate it by the lower right. And so we need some sort of way to tell the engine how to go about doing that. And we're going to actually do that with the origin. And what the origin is going to be is it's basically going to be a percentage from left to right and from top to bottom, represented by a floating point 0 to 1. And what that's going to basically do is say, from the top left, this is the percentage that we want to offset the origin. And so for the classes that we've got set up, which right now is just sprite and animated sprite, the only change that we need to make is actually in sprite. And then animated sprite will actually be able to take advantage of this as well. And we need to modify what's happening right here. This is basically where we need to add our origin information. So the first thing we're going to need to do is add a protected underscore origin. And we're going to make that a vector 3, and we're going to default it to vector3.0. Okay, and we're also going to add a getter and a setter for it. So origin, and that's going to be a vector3. Return this underscore origin, and public set origin value vector3, this underscore origin equals value. Great, so now we've got a default origin that we can further set up. Okay, so the next thing that we need to do is, like I said, we need to modify the vertices that are being created. And right now, we're actually using zeros that are sort of hard-coded in here as sort of the left and top. And then we're using the height and width as the right and the bottom. So we actually need to change that up a bit. And what we want to do is we want to go with a min and max for each of those things. So we want to say, let min x equals this.width times this dot underscore origin dot x. And now we actually want the negative of that, because this is going to offset the vertex in that direction. So we need to make sure that that is the negative value of that, to shift it basically to the left. Next, we need a max x, and that is going to equal this dot width times, and then in parentheses, 1.0 minus this underscore origin dot x. And the reason that we're subtracting from 1.0 is to sort of get the other side of the origin. So if it's not perfectly centered, on one side we might want 30%, and on the other side we'd need the opposite of that, which would be the 70%. So we subtract from 1, which is our 100%, to get that other percentage. So we're going to actually do the same thing for the y-axis, and thankfully in this case we can actually just copy these, modify them to use height, and whoops, and origin.y. Great. So those are all the calculations that we actually need to do. Now we just need to update our vertices to actually use them. So I'm going to replace these zeros with min x for the x component of our vertices. And I'm going to replace the this.width ones with max x. Okay? And then I'm going to do the same with y, so replace the zeros with min y, and replace the ones that are being loaded with this.height with max y. Okay. So just to make sure that we didn't break anything, let's go ahead and build and run. And we should actually see the same result. And we do. Great. So to prove that this works, temporarily I'm actually going to change the origin default value. I'm going to set that to new vector3, and instead of vector3 0, I'm going to set it to 0.5, 0.5, and I'll just set it for 0 to z on the z-axis because it doesn't really matter in this case. And I'm going to build and run. And now we can see both of these things are rotated perfectly in the center, which is exactly what we want. So now we have the ability to fully control where the position and rotation and scale of these objects is done from, just by changing the way that the vertex information is created from the start. Okay? And we'll actually need to recreate these vertices anytime this origin is updated. And this might not be optimal. In fact, we may want to add something perhaps to the shader later to sort of dynamically calculate this. And for right now, I'm not going to worry about that. So if you recall in our animated sprite, the way that we did this was we actually, for our texture coordinates, we updated it by basically clearing out the buffer data and pushing back new data and then re-uploading it to the GPU. So in our sprite, we're actually going to be doing something very similar to this. So yeah, let's go ahead and cut this code. I actually want to take everything after the attribute location, and I'm going to temporarily cut that. And I'm going to go ahead and create a protected calculate vertices. It's going to be return type void, and I'm just going to paste that code in there. And then in our load method, we can now say this.calculate vertices. And whenever we set our origin, we also want to call this.calculate vertices. Great. So now we should be able to update that in real time and be able to see the difference. So just to make sure that nothing is broken, perfect, it still works. Okay. Now, this is actually going to potentially create a problem if we just leave this as is for the animated sprite, because if we recall here, we update the text coordinates of the vertices, but we're not actually recalculating the entire thing. And so we actually need to add a second method here. It's going to be a protected, and we're going to say recalculate vertices. And this is actually going to recalculate just the position of all the vertices. So similar to how in animated sprite we recalculate the texture coordinates, we're going to be doing the same thing, but instead of that, we're actually going to be changing the position. So probably the easiest way to do this is I'm actually just going to copy this section of code here, and I'm going to get rid of all of this where it says new vertex, and I'm going to say, let's see, it should be this.vertices, and I'm going to say 0.position, and I really need a set on that. Let's go ahead and add a small convenience method to our vector3. We're gonna call this public. Set is going to be the name of the method. It's going to take in a x number. We're going to default that to 0. Actually, we're going to make that optional. Y number and Z number. Going to have a return type of void if x is not equal to undefined. This dot underscore x equals x. And I'm going to do the same thing for y and z. And z. Okay. And this is just going to allow us to easily set the values of this vector3 without having to sort of recopy the whole thing all the time. So now I can just say this vertices 0 position set, and all I have to do is set the min x and min y, which I actually need to copy from here as well. And that should be it. Great. So I'm just going to copy this code and paste it on all these lines here. Change these to semicolons. And I'm going to delete everything after the mins and maxes, because those are the only things we want to set. And format that. And then this is going to be 1, 2, 3, 4, 5. Okay? And then I'm actually going to need to do this.buffer.clear data. And I'm just going to copy the rest of this code here, so that now we can just recalculate vertices. So load is going to call calculate vertices, and our origin update is going to call recalculate vertices. And that should actually handle things properly without trampling what is going to happen in animated sprite with the texture coordinates. So, wound up being a little bit more complicated than I initially anticipated, but I think it's for the best. Let's go ahead and run this. Okay. All right. So the next thing that I want to do is actually for sprites. I need to change this back to vector 3.0 because we want our default to be vector 3.0. And we actually need a way to set this up from our data in our level. So in the sprite component, in our sprite component data, we need to add a new property. We're going to call this public origin, and it's going to be a vector 3. And we're actually going to default it to, again, vector 3.0. And here we're going to say if JSON.origin is not equal to undefined, then we're going to say this dot origin dot set from JSON dot origin. Okay. And in the sprite component itself, when we're setting up the sprite, right here in the constructor, we want to go ahead and say, we can do a check. We could say if data dot origin dot let's see. You know what? Let's add one more convenience method to our vector 3. Let's go ahead and create a public equals method. And we'll just say v vector 3 return type boolean. And we're actually just going to return this dot x equals v dot x and this dot y equals v dot y and this dot z equals v dot z. Instead of having to do all three of those checks anywhere in our code, we're going to go ahead and just add this quick method here to be able to do that sort of on the fly. Check if this vector is equal to the one passed in. The vector to check against. Okay. Alright, so now we can say if data.origin dot equals vector 3.0. And actually we want to say not equals. So basically what we're doing is we're only going to run this code if our origin is not the default. So that we then want to say this dot sprite dot origin dot copy from data dot origin. Okay, so now if we go to our zone, and we set origin on one of our components, or one of our, let's see. Let's go ahead and set it on the test like we did before. So we'll actually just say origin, and we'll say x, and we'll set this to 0.5, and y to 0.5. Okay. And that is all that we should actually need to do. Probably have to clear our cache. But now we can see here that because in our data we changed our origin, that it is actually updated. Although it looks like this one is still wrong. Right, because I didn't add the origin to the other one. So this is actually a good test, right? So I added the origin to the parent, but not the child. So you can see that the child actually still has, it's still rotating by, if you look closely, the upper left corner. So this again sort of illustrates how powerful the data system that we have to be able to configure these zones is, because we can apply this to one and not the other, and we could just make that change in line and have it right out of the box. Okay, so that is the origin. So the next thing that we need to set up is we need to set up some collision components. And collision components are basically, they're not going to be drawn to the screen, they are going to be representing a shape in space. And so what we're going to wind up with is, let's say for example we have a poorly drawn box or rectangle, and we want to check it against another poorly drawn rectangle. Whoops. To see if these two things collide. So our sprite might be, you know, in here or whatever, and it's surrounded by this red box here. And what we want to check is basically, does this red box collide with this blue box here? And in this case they don't, but we want to be able to check for when they do. So if we had, say, another purple box here, we'd be able to check, okay, this purple box intersects this red box and the blue box. Or if we had a green circle that's also poorly drawn here, like that, we'd also be able to say this this green circle intersects with this purple box here, but not the red box and not the blue box. So what we need to create are these boxes, which are going to then be used to determine collisions in the world. So, to do this, we actually need a couple of things. The first one of those things is going to be a... we actually need shapes. We need to define the shapes first. So under graphics, I'm going to create a new folder. We're going to call this Shapes 2D, because we might eventually expand this to be 3D later, so let's be explicit about that. In there, I want to add a new TypeScript file that we're going to call rectangle 2D. Okay, namespace TSE, export class rectangle 2D, and in fact we probably ought to have just a a generic shape that all these things inherit from. So let's create an interface for this actually. I'm going to create a new TypeScript file and I'm going to call this iShape. Namespace TSE, export, interface, iShape. Now, shapes all have different properties, but one thing that they all are going to have, you know what, let's call this iShape 2D for consistency. So one thing that all shapes are going to have is a position. So we need a public, whoops, this is interface. We need a position that's going to be of type vector2. And honestly, that's going to be about it for right now. But we may wind up adding to that later. So we'll say implements iShape 2D. Okay, so public position vector2 equals vector2 dot 0. Okay, and let's see. We actually want to do one more thing. Let's create a set from JSON method because we're actually going to want to create this from our zone file. So we'll say set from JSON type any, return type void. And I'm just going to copy that, paste it in here, mark it as public. Okay, and I'm going to say for right now if JSON dot position is not equal to undefined, then this dot position dot set from JSON dot position. There we go. Okay. And the next thing that a rectangle 2D allows is a width, which is a number. Let's go ahead and default this to, you know what, I'm not going to default that. Handle that in a second. Public height number. So in the JSON, we can then say if JSON.width equals undefined, we want to throw a new error. And we'll say rectangle 2D requires width to be present. Okay. Otherwise, we'll set this dot width to cast it to a number, JSON.width. And I'm just going to actually copy this and do the same thing for height. So height, and requires height to be present. Okay? Okay, so now this has all the properties that a rectangle should require for right now. The next thing that I need to do is add another method to iShape 2D. And this is going to be a intersects method. And it's going to take a iShape 2D and return a Boolean. And so this is going to leave it up to the individual shape classes themselves to determine what type of shapes that they can do intersects check with. So in this case, if shape instance of rectangle 2D, then we can go ahead and do our collision check here. But by default, we actually, if it's a shape that we're not aware of or don't know how to process, we're actually going to return false, saying that we don't collide with this because, or we don't intersect with this because we don't know how to deal with it. So each individual shape is going to be responsible for knowing how to check itself against another type of shape. So in this case, if the other shape is a rectangle 2D, then we can go ahead and check if this shape intersects with the other shape. So to do that, what we're actually going to do is a couple of simple checks. So if we go back to our super crude drawing here, let's say, for example, let me use these shapes instead. Let's say that we have a shape here. Oops. Right? And we have another shape right here. Okay? So what we need to do is figure out what needs to be checked to see if these intersect one another. And so in this case, we're actually going to start with the position, which is here and here. Okay? And so this is going to be A, and this is going to be B. So what we need to do is we basically need to look at this position and this position and determine if either one is between the two of the other one. So what I mean by that is, for example, we can see B's position.x is between the width of A and the x position of A. So that check would be true. And then what we'll need to do is do the same check with the y-axis. So we'll need to say, is B between y and y plus height? And if both of those things are true, we have an intersection. If we have another shape that is, let's say, here, or we have another shape that is, say, here, it's only going to pass one of those things. Right? So if we check our x first, we'll say, okay, this position here, is this between A? So we'll call this one C, we'll call this one D. Is C.x between A.x and A.x plus width? Yes, it is. But when we check the height, it's going to fail that because it's outside that, right? So we basically do that check with each of the 4 points of one of the rectangles against the other. So I hope that makes sense. That's a really crude explanation, but hopefully all that makes sense. So let's go ahead and write the code for that. So I'm actually going to call this other to make it clear which shape we're talking about. So let me just rename that. Okay. So what I'm going to do is say if other.position.x is greater than this.position.x and other.position.x is less than this.position.x plus this.width. And this is only going to say, technically this test is only going to pass if it's inside of this rectangle. It's not going to take edge cases into account. So to take edge cases into account, we need to say greater than or equal or less than or equal. And then if it's right on the edge, so in other words, if we have a box that looks like that, that's right on the edge, this will technically count as a collision as well. Okay? And so if we are inside, then we can go ahead and simply check the y-axis. So we can say if other.position.y is greater than or equal to this.position.y, and other.position.y is less than or equal to this.position.y plus this.height. Right? So if both of these things, or I should say all four of these checks are true, then we return true. Okay? If you recall, I mentioned that we have to do this check against all 4 points. Right? So basically we'd have to write out code to check all 4 of these points. Not exactly ideal. Right? So what we need is one more function, and that's going to be point and shape. And this is going to be called point. It's going to take a vector 2 and return boolean. So as you may have guessed, this is going to be a simple check to see if the point that's passed in is inside our shape. So I'm going to go ahead and mark this as public. Okay. And I'm actually going to copy this code. I'm going to cut it, rather, and paste it here. And I'm going to check, instead of saying other position, we're going to change other position to just point. Okay? And so now it's just checking to see if the point that's passed is inside our shape. If it's not, return false. Okay? And so now, what we can do is we can check all 4 of the points very easily. So we can say if this dot point in shape other dot position, okay, and then we'll say or this dot point in shape, and we're actually going to say new vector 2 other dot position dot x other dot width. Right, so we'll check that first, and then for the y we'll just say other dot position dot y. Okay, and then we'll say or this dot point in shape new vector 2 other dot position dot x plus other dot width other dot position dot y plus other dot height. And so that's going to check the max extents of it. And the last check is going to be this dot point in shape, and we'll say new vector 2 other dot other dot position dot x other dot position dot y plus other dot height. Okay, so if any of those are true, then our test succeeds and we return true. If all 4 of those checks are false, then we do not have a collision. We do not have an intersection, rather. Great. So this is all we need to do in our rectangle 2D class for right now, as far as that's concerned. The other thing that we want to do is we want to add a circle shape. So I'm going to add a new TypeScript file, and I'm going to call this circle2D. namespace TSE, export class circle 2D, implements I, shape 2D. Okay? And this one's also going to have a position that I'm going to default to 0. But this is going to have a different property. We're going to call this radius. That's just going to be a number. Okay? And I'm actually going to copy this set from JSON just to expedite things a little bit. And I'm going to get rid of height, and I'm going to replace width with radius. Right? So it requires a radius to be present. Okay, and then I'm just going to actually copy these functions as well. But I'm going to delete the implementation of them. Okay, so I actually realized that our vector2 class is missing some things that we need to add. So one thing that our vector3 has is we have these add, subtract, multiply, and divide. Our vector2 looks like we forgot to add those, so I'm just going to copy them from vector3 and paste them here and just get rid of the z-axis on all these. And then change these all to vector2. Okay? And the next thing that I want to do is I want to add a static method. And this is going to be public static distance. Okay? And this is going to be A, which is vector2, and B, which is vector2. And it's going to return a number. Cool. So the first thing that we want to do is we want to say let diff equal A dot subtract B. Okay, so we're going to get the difference between A and B, and then we're going to return the math dot square root of diff.x times diff.x plus diff.y times diff.y. And that's it. And just for the sake of completeness, I'm actually going to copy this over to vector3. And right above set, I'm going to put that here. Change these to vector3s. And add in the z-axis. So now we can calculate the distance between 2 points. So the whole reason that we need that is our point in shape is going to get the math.abs. So we're going to get the absolute value of the vector2 dot distance between this dot position and the point passed in. Okay, so that's going to be the let's call that the abs distance, right? So that's the absolute distance, so that we're not dealing with any sort of negative numbers here. We're just getting a straight distance factor here. And we're going to say if absolute distance is less than this dot radius, let's say less than or equal to, let's count the edge, return true. Otherwise, whoops. Otherwise, we want to return false. Right? So that's all we really have to do as far as this check goes. It's very simple. Okay, so the first intersects check is we want to say if other instance of circle 2D, then all we're basically going to do is get the distance between the two and check to see if their radii intersect. So the first thing that we're going to do is say we're going to get the distance between the two of them. So we'll say if vector2.distance other dot position this dot position. Actually, instead of ifing that, I'm going to save that off to a variable. So we'll say distance, and we want to say math.absolute because we don't want to deal with any negatives here. We don't need to. So we'll get the distance between these two. And that's going to be the center point of both of the circles. Next, we'll get the radius lengths, and that's just going to be this dot radius plus other dot radius. Okay, and if the distance is less than radius lengths, return true. And let's actually say less than or equal again to include the edge detection. So basically we're saying if the two center points are closer together than the combined radius of both circles, then they're colliding. Otherwise they're not. Okay? The next thing we're going to do is if other instance of rectangle 2D. In fact, this same check is actually going to work. It's going to be very similar to this check. It's not going to be exactly the same. So what we're going to do is we're going to do sort of the opposite of what's happening in here. So all the ones that are marked as other, we're actually going to pass this. Okay? So instead of this dot point and shape, we're going to say other dot point and shape. There we go. Okay, and so that sort of just reverses the role of the check. So this is basically asking the circle, hey, is this point inside of you or not? And then if any of those are true, we have a intersection. Alright, so that right now is going to wrap it up for the shapes. That's all we're going to do, is just we're going to support these two shapes. One thing that I do want to point out is for now we're only supporting axis aligned rectangles. So we're not going to be able to support rotated rectangles or anything like that. We may support that down the road, but for right now we're not going to be supporting that. So for right now it's just going to be aligned along the X and Y axis. Because especially for our simple game, that's all we're going to need. We can always add to it later, but for now it's just going to be these simple checks. Okay, so the last thing that I want to do is add a collision component. So under components, I'm going to add, you know what, let me actually, I'm going to copy the sprite component class, and I'm going to add a new TypeScript file, and I'm going to call this, let's call it collision component. Yeah, that'll work for now. Okay, and let's just rename this to collision component data, sprite, collision component builder, collision component. Change the type on this to collision. Okay, and so on the component itself, we're going to replace sprite with shape, and this is going to be a I shape 2D, and this is actually going to be collision component data that gets passed into the constructor, and we're going to say this shape equals, let's see, so we've actually got we have set from JSON, but we have no way to actually determine what type of shape we're going to be passed. Okay, so the next thing that I need to do is I actually need to copy this over from our component data, but I haven't actually set up the component data yet. So let's go ahead and do that. So I can get rid of both of these things. I have a name. The next thing that I want to set up is a shape, and it's going to be an iShape 2D. And we'll go ahead and say if JSON.shape is undefined, then we want to throw new error. Collision component data requires shape to be present. Okay, and then otherwise, let's look at if JSON.shape.type is not equal to undefined. Actually, let's check equality to undefined, because if we don't pass a type, we're not going to be able to tell what type of shape to create. So we actually need to throw another error. Collision component data requires shape.type to be present. Okay, so let's switch on string JSON.shape.type, and we'll to lowercase that, just to be on the safe side. And we'll say case rectangle break, and we'll also have a case circle, and we'll break. Okay, so now we can say this.shape equals new rectangle 2D. We could say this.shape equals new circle 2D. Again, this is not the ideal way of creating this. We should really come up with some sort of factory that will be able to handle this instead. But for right now, these are the only two things that we want to support, so this is fine. Okay, let's also be safe and create a default case. Unsupported shape type, and we'll just let's cut this. Let's put this up here. Shape type. Switch on shape type, and that way I can use it down here too. Great. Okay, so if we pass something else besides these two, then we'll throw an error. Always better safe than sorry. Okay, so the next thing that we'll need to do is call this.shape.setFromJSON, and we get that because even though we don't know what kind of a shape it is at this level, we only know here, our interface provides that. So we can say JSON.shape and just pass that in. And that way it will be fully populated. Great. So now we have our collision component data. Let's change these classes to be and the builder to be the correct ones. Okay, and then all we should need to do is this shape equals data.shape. Okay, And we don't have a load, so actually I should be able to get rid of that entirely. And this also doesn't render, although we may at some point want to render for debug purposes, so I'm actually not going to completely get rid of this yet. Next thing, let's create an accessor. iShape2D. Just so that we can actually access the shape later on. And we will register the builder here. And I think that's everything we actually need to do. Okay. So let's go ahead in our zone and add a collision to our duck. So under components, we want to create a new object. We're going to name duck collision. And it's going to have a shape, which is an object itself. And its type is going to be circle. Its radius is, let's see, its frame width is the largest number, which is 17. I think I'm actually going to go ahead and stick with 17. But we do have, so one thing that we may have to take into account is scale as well. I'm actually not going to worry about that for right now. I'm just going to do this manually. So if we do 17 times 8 is 136, right? So we're going to want, well, 136 is going to wind up being our diameter, so we actually need to divide that by 2, which is 68. So our radius is going to be 68. Now, oops, 68. Obviously, we probably ought to make this look at the scale of what it's attached to, but for right now, I think this will work just fine. So we're going to attach a collision that's of type circle with a radius of 68 to our duck. Okay, so let's go ahead and build this, run it. Looks like we may have gotten an error. Let me just refresh this real quick. So, component set owner. Component is undefined. What is going on here? So we've extracted a component. Here's our data, but the component is undefined. Probably ought to put in some sort of error checking here on our load sim object. If our component comes back undefined, we probably ought to catch that error. Okay, I don't know why that's happening, so let's have a quick look here. Sim object. So if component, actually I'm thinking the component manager itself probably ought to catch that. Oh, I see the problem. That's interesting though. It should have been... Okay, so the type was missing here. But it's interesting that the component manager didn't actually catch that the type was missing. Aha. Okay. This is actually... I see the problem. Okay, actually, I could just solve this by moving this down here. Okay, so minor bug, actually kind of a major bug. So only if JSON.type was undefined and then we didn't have a registered builder that handled that type of component, only then did we throw this error. So if the type was undefined like it was in our configuration for our zone here, if that wasn't defined, that error wouldn't have been caught. And so that's why we are getting an undefined component returned from this method. Okay, and there we go. So now it works. So no errors. Okay, we're good to go. Okay, so this video is already gone on for quite a long time. So I'm actually going to split this collision detection into two parts. So in the next video, we're going to go ahead and create our collision manager and start doing actual collision detections in the scene. We're going to clean up a couple of things, get rid of these rotating crates because we no longer need them, and start actually making collisions happen and you know, getting some sort of gameplay mechanics underway. So I hope this video helped you guys understand a bit about some collision detection, at least the starting of it. Thank you so much for watching. I hope you enjoyed this video. I hope you learned, and I will see you guys in the next video.